Okay, today we're looking at experimental probability. We'll do this in two parts, okay? So this is part one today. Okay, so just make an experiment. Let's say we tossed a coin 40 times, and a normal coin, and we got 22 times it came up as heads and 18 times it came up as tails. Okay, now that would be, called running an experiment. And the heads is an outcome and the tails is an outcome. And there were 40 trials, okay, 22 plus 18. Right, now, the relative frequency, which is a term that's going to be used a lot in experimental probability, okay, the relative frequency refers to a particular outcome. So in this one, it's of heads. All right, so there was simple fraction. There were 22 heads out of 40 times the coin was tossed. Okay, so that's relative frequency. And just to put it in words, it is the frequency of an outcome, okay, in our case heads, but of a particular outcome, divided by the total number of trials. Okay, so for the frequency, the relative frequency of tails, there was 18 tails, again, out of a total of 40 trials. Okay, a question you'll get asked a bit is adding those two relative frequencies together. So we get 22 out of 40 were heads, plus 18 out of 40 were tails, and that equals 40 out of 40, which equals 1. Now that will always happen if you add all the relative frequencies, all the outcomes of a particular trial, and you add them up, you'll always get 1, okay? All right, now experimental probability, which is the name of the actual topic, is exactly the same for our purposes as relative frequency, okay? More or less mean exactly the same thing, okay? And so the definition, or the way to work out an experimental probability is exactly the same as working out the relative frequency. So it's the frequency of outcomes divided by the total number of trials. Okay. Now, experimental probability is not exactly the same as theoretical probability, and we'll discuss the differences a little bit later. Okay, an experimental probability tends to be used to work out probabilities of events or of outcomes that are too hard to work out theoretically. Now, an example is question 4a, and they talk about throwing a dice, but the dice is not a normal dice. So each of the 6 outcomes does not have an equal outcome or an equal probability. So they don't explain exactly how the dice is loaded or rigged, but we know that it is. And so we look at the outcomes, and they aren't even. They aren't even close to even. Normally if you throw a dice 600 times, you'd expect approximately close to 100 of each number. Okay, they're well out on this. So they use experimental probability to get an idea of what the probability of each number comes up as. Now they threw the dice 200 times, so that's the number of trials. And how many 6s came up? It was 73. So as simple as that. Now I think at the front they use the terminology probability of a 6. Okay, that's what that terminology means. Find the probability of 6 coming up. It's 73 out of 200 based on the results of that trial. Now that should be enough to get you through questions 1 to 5. Thank you.